Good evening, guys. Welcome to today's session. So this is day 6. So in day 6, we are going to see how we are going to implement neural networks. Okay, we are going to see how we are going to implement neural networks. So how it will be useful for us. So what the robotics is going to do in neural networks. So as I said, guys, neural networks is nothing but which mimics human brain, right? So neural network is nothing but which mimics human brain. Okay, it's going to mimic our human brain, guys. It's going to act like us. So for your better understanding, you can say this as, let me say, a neuron. Okay, a neuron, right? So it's going to mimic our human brain, this neural networks. So in the last few sessions, we have seen how to clean the data. Day 1, day 2, day 3. We have understood the agenda. So what we are going to implement, right? And day 4, we have seen what is meant by KNN. And day 5, we have seen what is meant by K-means clustering. So how to implement the robotics analytics, right? So in today's session, we are going to see what is meant by neural network, okay? And how we are going to implement that, okay? So neural network, it is nothing but an artificial network, usually called as neural networks, okay? So let me write it down for you. So what is this neural networks? This artificial neural networks. Okay, usually it is called as artificial networks is called as neural networks and are computing system inspired by the biological neural networks that constitute animal brains. Okay, as I said, guys, for simple understanding, I'm going with animals and money, but it's gonna be human brain. Okay, this ANN is, guys, we say neural networks, the ANN. The ANN is based on collection of connected units or nodes called as artificial neurons. Okay, this artificial neurons basically gonna say which neurons to get activated, which neurons to get not to get activated. Okay, that is the reason why we are going to use neural networks. And if you're going to ask me, so why we are going to use neural networks? These neural networks can help computers make intelligent decisions, guys. Okay, it is useful us to make intelligent decision with limited human assistance. Okay, so this is all about artificial neural networks. Okay, so the relationship between input and output that are non-linear or the complex things. Okay, in neural networks, the relationship may be between the input and output are non-linear and complex. Okay, so if you want me to explain this neural network more deeply, a neural network is a series of algorithms that endeavors to recognize underlying relationship in set of data through a process that mimics the way of human brain operates. As I said, guys, I'm stressing the word mimic. Okay, this neural network is completely based on mimicking human brain. It's gonna go with the flow, how the human brain works. Okay, so it's gonna mimic human brain. In the sense, neural network refers to system of neurons. Okay, as we know, as I said, neurons, guys. So let me give an example. So if you touch any hot pan or any hot thing by your hand, it's gonna send a message to the brain suddenly, right? So it's hot, so you take off your hand suddenly, right? So how it is done? It is done by neural network, guys. The neurons is attached for them. Okay, so this neural networks refers to a system of neurons. The same thing is happening in the machine too, either organic or artificial in nature. Okay, so what are this neural network and what are its types? We're going to see in the upcoming slides, guys. But for your hint, I'm going to say what are type of neural network models we have. We have feed-forward neural network. We have multiple player perceptron. We have convolutional neural networks. Is nothing but CNN. Okay, and we have radial basis functional neural network. We have like RNN, nothing but recurrent neural network. Okay, so these many type of neural networks we have, but we are going to concentrate which are very useful for us in this robotics. Okay, so we have seen what is meant by neural network. As I said, a node. So what is meant by a node? Okay, a node is also called as a neuron or perceptron. It is a computational unit that has one or more weighted input connections. Okay, it's going to transfer a function, guys. It's going to transfer a function that combines the inputs in some way and output as a connection. Okay. So a node is nothing but it is called as a neuron or perceptron, guys. It is a computational unit that has one or more weighted input connections, and it has a transfer function that combines the inputs in some way and output in the way of connection. Okay. So this is all about the neural network, guys. Okay. We are seeing what is meant by neural networks. Okay. So moving on, I'm going to explain some terminologies which are very important. Okay. So let me clear my text and we're going to move on. So agenda, what is we are going to learn in this video? Neural networks, okay, how we are going to implement on that. And neural network primer, perceptron, activation function, error phase, okay. So this is how the neurons are worked, guys, okay. This is how neurons are worked. How it's going to mimic human brain, okay. We're going to see how it is going to mimic human brain. Okay. So as we saw in the last thing, we are going to see what is meant by neural networks in robotic analytics. So this is neuron, guys, and we are going to see what is the thing. Okay. So let me take a thing. Okay. So basically, okay, so as I said, guys, we are gonna see what is meant by neural networks. Okay, neurons, what all we have. So how it is gonna mimic human brain. Okay, let me explain you this, and we're gonna go for the agenda. So here, a neuron, guys. I think you have heard about that. The neurons, right? You heard about neurons in school times also. Okay, so it is called as a nucleus, guys. Okay, it is center of the body, the neuron, and we have axon terminals, and it is called as a cell body. Okay, how can we make human brain? So it is done by artificial neural network. Okay, so the input signal, you can see the chart, guys. Okay, so let me show you that. 1 second. Okay, input signals is X and dendrites. Okay, this is called as dendrites, guys. Okay, see here it has written dendrites. It is called as dendrites. Okay, so input signal, we have some values going on. As I said, guys, if you are gonna touch anything, hot thing, it's gonna directly send a message to brain. The same thing happening here, guys. Okay, see here the variable, the input signal has been sent to the all the hidden layers. It has been communicated to all the hidden layers. See, guys, you can just see all the hidden layers has been connected, right? So after that, X2, X3 also is coming to all the hidden layers, and after the hidden layers, it's gonna take the values which are in the hidden layers and it's gonna send to the output layers, guys. Okay, it's gonna send to the output layers. So after sending to the output layers, you can see it has given one result. So we have so many hidden layers. So after sending the connection to the hidden layers, it has been sent to so many. Okay, and we are gonna go for the output layers after that. So we are gonna go for the output layer which has been we got. Okay, so we'll go to the agenda. We're gonna see what is the agenda, guys. Okay, neural networks in robotic data analytics. So how we are going to implement this neural network in robotic data analytics? Okay, so the robotic analytics is, guys, is nothing but where you have different type of things where you're gonna see how the robot is gonna work. Okay, so basically you're gonna see how the robot is implemented in these artificial neural networks. So what are the things you have to do? Okay. So neural network primer. So what is this neural network primer? Right? So the question arises, sir, the neural network primer is the same? So guys, a neural network primer is a primer that introduces fundamental concepts used in networks and deep learning. Okay. We have seen it, right? So in the session we have seen this is the neural networks, which has used concepts of deep learning. Thus, okay. So a primer that introduces fundamental, okay, that uses fundamental concepts used in neural networks and deep learning. Okay, this neural network primer, guys, is very important in the concept of this AN. Okay, so what are the neural network primer basics? The fundamental unit of neural network is neuron, as I said. So it's a biological neuron, an artificial neuron is a computational unit that can receive some input, process it, propagate it. Okay, we are going to illustrate what all the neural networks we have. Okay, so as I said, guys, it is nothing but when we have which is a fundamental concept for us. Okay, primer that introduces fundamental concepts used in neural networks and deep learning. I'm assuming that that is clear, and I'm going to go for perceptron and multiple layered perceptron algorithm. So what is this is perceptron? Okay, in machine learning, guys, I'm going to explain perceptron, and I'm going to go for multiple layered. It is easy. Okay, perceptron. The machine learning perceptron is an algorithm for supervised learning of binary classifiers. A binary classifier is a function which can decide whether or not an input. So basically, it's going to decide it is an input or not an input. It is represented by vector of numbers. It belongs to some specific class too. Okay. So as I said, guys, the machine learning perceptron is the algorithm. Okay. The machine learning primer is an algorithm in a supervised learning for binary classifiers. A binary classifier is a function. Okay, it's a function of classifier which can decide whether it's an output or not. Okay, so this is what is meant by perceptron. So I assume if you have clear what is meant by perceptron, and you'll be able to answer what is meant by multiple layered perceptron. Okay. So multi-layer, the name itself indicates multi, more than 4 or 5, right? Multiple layer. So what is this multiple layer perceptron algorithm? A multiple layer perceptron is a fully connected class of feed forward artificial neural network. Okay, feed forward artificial neural network. Okay, a multiple layer perceptron is a fully connected class of feed forward artificial neural network. The term MLP, guys, okay, this is called as MLP. MLP, the term MLP is used basically in some ambiguously based guys. Sometimes chosen to mean an input feed forward AN. Sometimes it refers to network composed of multiple layers. This MLP refers to all guys, okay, not only for feed forward AN. This strictly refers to network composed of multiple layers too. So, okay, what does this multiple layer perceptron do? So the neurons in the MLP, the neurons in the MLP are trained in the back of propagation learning algorithm. Okay, it is learned in propagation learning algorithm. This MLP, guys. So this MLP is basically trained with back propagation learning algorithm. Okay, MLPs are designed like basically I can say to approximate any continuous function and can solve problems which are not linearly separable. Okay, so these MLPs are designed to approximately any continuous function and can solve problems which are not linearly separable. Okay, so what is perceptron and multiple layer perceptron? Okay, the question. Perceptron is guys is a neural network with only one neuron. Okay, my bad, it's neuron. Perceptron is a neural network with only one neuron and can only understand linear relationship between the input and output data provided. Okay, perceptron is a neural network with only one neuron and can only understand linear relationship between the input and output data provided. However, with this multiple layer perceptron, horizons are expanded, and now this neural network can have many layers of neurons and ready to learn more complex patterns. Okay, the perceptron is a neural network with only one neuron and can only understand linear relationship between input and output data. However, the multiple layer perceptron horizons are expanded, and this neural network can have many layers of neurons. Okay. So how do we calculate this multiple layer perceptron? Good question. So the formula is y is equal to f of wxt plus b. Okay, where f is the activation function. Okay. And w is set of parameter. And x is the input vector. And b is the bias vector. Okay, this is the formula, guys. Now we are going to calculate multiple layer perceptron. Okay, and I assume that is clear. So we'll move on to the next slides. So what is activation function? So what is meant by activation functions? So what is that? So in activation function, we are going to see what is meant by that. Okay. So what is this activation function called as? Right? In artificial neural networks, the activation function of a node defines the output of node given in input or set of inputs. Okay. So basically, it's going to see what is meant by artificial neural network in activation function. So activation function. So guys, what does this activation function do? An activation function decides whether the neuron should be activated or not. So it decides what the activation function should be done or not. Okay. So we have seen what is meant by activation function. Okay. So after activation function, neuron should be okay. So the activation function decides whether neuron should be activated or not. Okay. That means it will decide which neurons to get activated, which neurons to get not to activate. Okay. So as we have seen what is the activation function, we are going to see what are the concepts it can cover, right? So this activation function does, it's basically work as on and off. Okay, it works as on and off. Which neurons to get activated, which neurons get not to get activated. Okay, what is activation function in types? An activation function is a very important feature of artificial neural network. They basically decide whether the neuron should be activated or not. Okay. Basically, they're going to decide the neuron should be activated or not. They decide. Okay. This was all about activation function. We are going to see what is meant by error phase. So what is this error phase? The name itself indicates error surface, right? So what is this error surface? So how to solve this? Okay. Error surface, guys, it is fixed by training set. The error is function of the weights. The error surface, it is in the propagation of algorithm. The error in the output is reduced by changing the weight vector in the direction of opposite of the gradient and the error of the respect of the weights. Okay. So basically, we are going to see what is meant by that. Okay. So with a fixed training of set, the error is a function of the weights. Okay. So we have seen that. And after that error surface, we're going to see what is meant by gradient descent algorithm. Okay, gradient descent algorithm. Okay, so what is this gradient descent algorithm? Gradient descent is an optimization algorithm used for minimizing the cost function in various machine learning algorithms. Okay, gradient descent is an optimization, guys. It is an algorithm that is used for minimizing the cost function in various machine learning algorithms. So what does this gradient descent algorithm do? So what does this gradient descent algorithm do? Okay. So gradient descent is an optimization algorithm which is commonly used to train machine learning models and neural networks. Okay. Gradient descent is an optimization algorithm which is commonly used to train which is the data sets we. Okay, so this is artificial neural network. So this gradient descent algorithm is where common used to train the machine learning models in what ways. So we are going to see. So we are going to see the neural networks. What are their types? Okay. Okay. So training data helps these models learn over time, and cost function with gradient function decently specifically. So sorry for that, guys. With gradient descent specifically, we're going to see what is the barometer, what is the accuracy with each iteration of parameter of. Okay. So after this, we're going to see what is a use case. Okay. So as we have seen this dendrites of neural networks, we are going to go for neural networks. So what are types of neural networks we have? We have three types, guys: artificial neural network or multiple layer perceptron (MLP), and we have convolutional neural networks, and we have recurrent neural networks. Okay, what is meant by ANN, artificial neural network? We have seen, guys, it is nothing but simply called as neural networks or neural networks, computing systems inspired by biological neural networks and constitute animal brains. And ANN is based on collection of connected units. Okay. So what is ANN? In attempt to stimulate the network of this ANN, we are going to make up human brain. Okay. So the computer will be able to learn things and make decisions in like human-like manner. Okay. So basically, we are going to see how this ANN is going to work. So artificial neural network is going to make is an attempt to stimulate the neural network neurons. And we are going to see what are different type of neural networks we have. We have convolutional neural networks, we have artificial neural networks, and we have recurrent neural networks too. Okay, it's going to make up human brain. In what type of data we are going to use? Okay, so as artificial neural networks, we are going to see is a human-like structure. So how to implement that using this ANN? Okay, so after that, we are going to see what is meant by CNN. Okay, what is meant by CNN? So CNN is nothing but convolutional neural network, guys. Okay, so it's gonna detect the objects. Okay, so the convolutional neural networks. So why we are gonna use this? The convolutional neural network is a subset of machine learning. Okay? It is one of the various type of artificial neural networks which are used for different application and different data types. Basically, to recognize the objects, we are going to use CNN. Okay, and CNN is called as convolutional neural networks. It is a subset of machine learning and it is one of the various type of artificial neural networks. Okay, where we are gonna use it for different application and different data types. What is a CNN, right? And what is the purpose of that? Is CNN good for regression? Okay, that question. Yes, the CNN may be used for predicting continuous data such as an angle distance, and you can include regression layer at the end of the work. Okay. So what is meant by RNN? Recurrent neural network. Okay. What is RNN used for? And recurrent neural networks is a class of artificial neural networks where connection between nodes can create a cycle allowing output from some nodes. Okay. What is RNN used for? A recurrent neural network is a type of artificial neural networks common used in speech recognition. Okay. Basically, RNN is used in speech recognition and natural language processing, nothing but NLP. Okay. It is used in this class. For example, you can call as Alexa or Siri, right? Where we are going to use NLP, where we are going to convert words to text and text to binary objects like 1 and 0, where machine can understand. Okay. So that is meant by recurrent neural networks, guys. Okay. And we have seen this recurrent neural networks. It's enable you to model time dependent on sequential data and such as stocks. Okay. So this is the reason why we are going to use recurrent neural networks. And we have three types of neural networks. We have ANN, CNN, and RN. Okay. So we have seen ANN, artificial neural networks, recurrent neural networks, and we have convolutional neural networks. Okay. So here you can see the human brain is made up of 85 billion neurons. Okay. There is for only one neuron, we're going to work that much means, guys, the human brain is made up of 85 billion neurons. Don't get shocked here because we have requesting. So you can see a cat has roughly a billion neurons. Okay. A cat has billion neurons and a mouse has about 75 neurons. Okay. 75 million neurons. And a cockroach has only about a million neurons. Okay. These type of things we have. Okay. This type of neural networks we have. Okay. So in hundreds, so we are not worried about, we are not in any danger for creating an artificial brain in any time in the near future. So because we have that much of neurons, we should not be worried about any neurons we lost, like 1 or 2, because we have billions of neurons. Okay. So as we continue, we're going to see. So neural networks, guys. Okay. So depending upon the neurons, we're going to go for perceptron and algorithm. Okay. So perceptron algorithm, guys. So we are going to see what is this perceptron algorithm. Okay. What is meant by this perceptron algorithm? So why we are going to use this perceptron algorithm? Okay. So what is the use of this? So perceptron algorithm, guys. It is a neural networks. Okay. You can see it is an algorithm. Is a two-class classification machine learning algorithm. The building blocks or neural networks are neurons, weights, and activation function. It has a single node of neuron that takes a row of data as input and predicts a class name. Okay. So in machine learning, the perceptron is an algorithm. For supervised learning or binary classifier, a binary classifier is a function which can decide whether or not an input. Okay. It is represented by a vector of numbers belong to some specific class. Okay. In machine learning, the perceptron is an algorithm for supervised learning of binary classifiers. Okay. This is achieved by calculating the weighted sum of inputs. So we're going to go for activation function, weight stars input plus bias. If the activation is above 0.00, okay, the activation is above 0.00, the model will output 1.0. Otherwise, the output will be 0.0. Okay. If activation is greater than 0.00, or if the activation is lesser than or equal to 0.00, as the inputs are multiplied by model coefficients, it's going to increase linear regression and logistic regression. Okay, normalization or standardization. It's going to use successful approach to. Okay, so basically we are going to see what is meant by perceptron algorithm. So perceptron algorithm, it's basically for weighted summaries. Okay, where we are going to use what is the linear regression or logistic regression. What is the purpose of that? Okay, so what is the purpose of this? So this activation function is, guys, basically is going to decide which neurons to get activated and which neurons to get not to activated. Okay. So we are going to see. So we are going to see what is meant by this activation function. Okay. So this activation function, guys, we're basically going to see what is this perceptron algorithm is going to do. Okay, and what is the importance of this activation function. So we are going to see what is meant by the. Okay, we are going to see what is meant by the activation functions. Okay, so moving on, guys, we are going to see what is this perceptron algorithm is does kind of. Okay, the perceptron algorithm initializes with the vector WO. Repeat until the error is less than a threshold value for each iteration. So for layer, the point is straight or linear. You are going to see what is meant by that. Okay, you are going to see is perceptron algorithm is good for us, or it's going to see what is the advantage of this perceptron algorithm. Okay. So as moving on, we're going to see the perceptron algorithm in theoretical way, guys, in practical way. Okay, I'm going to show you the graph, and the neuron is explained how this neuron is going to work. Okay, so when you are going to set input vector and we're going to set output, the integration function, the activation function is threshold logic. Okay, it was proposed by Bloch and Pitts by MP neurons. Okay. So moving on, we're going to see what is meant by multiple layer perceptron. So what is this MLP? So multiple layer perceptron is a supplement of feed forward neural network. As I said, guys, I have explained you the agenda. Multiple layer perceptron is nothing but a feed forward neural network. It consists of three types: input layer, output layer, and hidden layer. The input layer receives the input signal to be processed. The required tasks such as prediction and classification is performed by the output layer. Okay. So the input layer receives the input signal. Required take prediction and classification. Okay, based on the output layer. So number of hidden layers that are placed in between input and output layer is the computational engine of the MLP. Okay. We are going to see how this MLP is going to work. Okay. So what is this hidden layer? Okay. So what is this hidden layer? So why we are going to use this hidden layer? So moving on, we are going to see what is meant by activation function. Basically decides which neurons to get activated, and it's going to work like on and off class. Okay. It's basically decides which neurons to get activated and which neurons to get not to get activated. Okay, it's basically going to say which neurons to get activated, which neurons not to get activated. Okay, so it's like on and off this. Okay, so the ReLU, what is meant by this ReLU? ReLU is nothing but rectified linear unit. Okay, ReLU is nothing but a rectified linear unit. For this exponential, the other form of rate is ELU, exponential linear unit. Okay, the softest form. So after that, we have seen error surface. So what is meant by error surface? A central theme in neural network research is to find right network for the problem. Okay, it is a central theme in neural network research where it's going to find the right net of the architecture. What is meant by this gradient descent algorithm? So in GD, the gradient descent algorithm, the first order of the optimization is algorithm used for local minimum and maximum. The method is common used in machine learning and deep learning. Okay, it minimizes the cost and the loss function. Okay, example is we have seen linear regression. Use cases, I'm going to show you what are libraries I'm going to use. Okay, so what is meant by EDA? We are going to do exploratory data analysis where we are going to clean the data, upload the data, right? We are going to do this ED. Okay, and we are going to see what is the purpose of this EDA. So what is the purpose of this EDA and how to implement that? And we are going to see scaling and data split. So how we are going to split the data and scale the data. Okay, and after that we are going to build model building. So what are the functions we are going to use? How we are going to use this ReLU and all. Okay, so the results will be like this. So thank you for this, guys. So I'm going to show you the code now. Okay, the code. You can see robotics neural networks code. Okay, so here, guys, I'm going to import some libraries. Okay, I'm going to import pandas SPD. Okay, we know panda is used for data visualization. Okay, pandas is used for data visualization. Okay, and we are going to import from TensorFlow. We are going to import dense. So why we are going to use that? I'm going to show you what is the purpose of that library, and we are going to go for how to import necessary libraries for MLP. Okay, from TensorFlow.keras models, we are going to import sequential data. Okay, we are going to import sequential data using this TensorFlow. After that, we are going to import pandas SPD. Okay, we are going to import panda. We know pandas is for data visualization, and I'm going to import NumPy for numerical calculator. And from Keras, we are going to import np.utils. Okay, Keras. So what is meant by that Keras? Keras is an API designed for human beings, guys. Okay, not machines. Keras follows the best practice for reducing cognitive load. Okay, what is Keras for? This Keras is a high-level deep learning API developed by Google for implementing in neural networks. It is basically developed by Google for implementing on neural networks. Okay, it is done in Python and it is used to make implementation of neural networks very easily. Okay, we're going to use Keras because it is very easy to use. Okay, which was developed by Google. Okay, which was developed by Google, and it was written in Python, and it is used to make implementation of networks very easy. What is Keras and TensorFlow? TensorFlow is an open source end-to-end platform, guys. Okay, so I don't want to dig into this TensorFlow. So we are going to see what are the sequential data. So here you can see train is equal to pd.csv. Okay. So I have loaded the data in the form of CSV file. Okay. So I'm going to go for the data which we have. I'm going to search for the tail. Okay. So here in neural networks, my machine is going to search for what are the data types, what are the numerical numbers we have. It's going to identify what type of data we have. Okay. So we are going to go for train.chill, but it is going to give what is the value of that. And we are going to predict the data, and we are going to see how to use this prediction. Okay. Okay, we are going to see what is meant by that. So this is how we are going to use train.shape. Okay. So we are going to see how to use this CSV data file. Okay. So after that, we are going to use test.takes. So train.shape, how to use this train.sample.csv. Test.shape. Okay. So what is the shape we are going to get? X is equal to train.ilogs, and value is for float. Okay. So using float, what we have. Okay. So after using this float in this neural networks, we are going to see what are the inputs we have. So how we are going to work on this input. Okay. Normalize the input. How we are going to input the fall. How this entire data with 255 max pixel value. Okay. Why we are going to use this one-not encoding, guys? So we are going to use one-not encoding. Basically, it's in 1.0 where the customer says, the client says only he and he should understand. For that, we are going to use one-not encoding. Storing of the number of classes in the variable number of classes. Okay. X is X underscore train dot check and Y test dot check. So we are going to use that. Okay. So creating a user-defined function. A user-defined function is nothing but this, a function where you can develop, okay, where you can write a code, the user-defined function. And for the model, we are going to write it in the ANN form. Okay. Model is equal to sequential. Model dot add dense. We're going to add dense, guys. And after adding dense, we're going to use the dimension as 784. Okay. I'm going to use dimension as 784. And the activation is RELU or rectified linear unit. Okay. And model dot add dense 200 activation is equal to tan h. Okay, I'm going to use the function tan h and I'm going to use the dense as 100 again. So here you can see I have used softmax function. Okay. I have used softmax activation function, right? The softmax function is nothing but, guys, is also called as softmax normalized exponential function. It's going to convert a vector of k real numbers into probability distribution of k of possible outcomes. Okay. This softmax is nothing but it's going to convert a vector. Basically, it's going to convert a vector of k real numbers into a probability distribution of k possible outcomes. Okay. So the formula for this is easy, guys. So how this softmax function is going to work here? So the softmax function is a function that turns a vector of k real values into a vector of k real values that sum 0 is to 1. Okay. It's going to turn a vector of k real values into a vector of k real values that sum to 1. The input values can be positive, negative, 0, or greater than 1. Okay. So I'm going to use this softmax function and I'm going to use categorical cross entropy. Okay, I'm going to use categorical cross entropy and the metrics I'm going to use is accuracy. Okay. So after that, I'm going to go with building ANN model. After using all the function, I'm going to build ANN model. Okay. ANN model using train data set and validation data set. Okay. MLP, multiple layer perceptron. I'm going to fit the model on train data. Okay. I'm going to fit the model on train data. Okay. So after that, fitting data on train model data, I'm going to fit a function on train data. Okay. So model is equal to fit train, white train, batch size, and epochs we are going to see. Okay. So after that, we are going to go for model.summary. We are going to see what is summary, what is the epoch going on. Okay. Epoch, as I said, I'm going to take epoch of 10 to find my model is working good or not. Okay. So after that, I'm going to go with epochs. So you can see what is the loss and what is the accuracy we are getting for ANN model. Okay. So epoch 1 of 10 is going to give us the loss of 1.066 and the accuracy we're going to get is good accuracy guys 0.4798. Okay. So after 10 epochs, what is the sequential data we are getting? So after 10 epochs, we are going to get the accuracy of 0.9318, which is good, the right fit model, right? Well, we can implement that. The loss we can see and the accuracy you can see. The accuracy is more than loss, right? So the model is sequential. Okay. And we are going to go for output type. So what is the output shape we have got? What is the layer type? Okay. Dense of dense, dense of 1, dense of 2, dense of 3. Okay. So after that, we are going to see how to evaluate that model or test data. So what is the accuracy we have got for ANN model? Okay. So I'm going to evaluate the model or test data by applying this ANN. So I'm going to print the accuracy, what we have got. So print accuracy $3 per off, and we're going to see how to evaluate the score. Okay, how to evaluate the score, and I'm going to test accuracy on data set. How to test accuracy? Okay, and we're going to see what is the accuracy we have got. So we have got the accuracy for test data is 88.700%. Okay, so this is the accuracy which we have got. So for trained data set, the accuracy of model evaluation, what is we got for evaluation score of verbose? Okay, for accuracy we have got this, and we're gonna evaluate the trained model. So here I wanted to focus. We are gonna evaluate score test here. Okay, and we are gonna evaluate score training. Okay. So after evaluating everything, guys, we are going to see which accuracy is good. Okay, which accuracy is good for us. So accuracy on trained data, we have got 90% of 380%. Okay, and accuracy on test data, we have got is 88.700%. Okay, this is the accuracy which we have got, guys. Okay. So this was all about artificial neural network. Okay. So what is this robotics is gonna do? The robotics is gonna find what is the data set we have. Okay. It's gonna find out what type of data can we use 1001 type. Okay. So and we are gonna see what type of values we have. These are values. We are gonna see encoding output. So we are going to use one-hot encoding. We are going to normalize the input where it is falls under 0, 1. So it's going to give us the values where it is going to fall on 0 or it is going to fall on 0, 1. And we're going to go for the maximum value. And after that, we're going to normalize the inputs. And we're going to do one-hot encoding output for both trained and test data set. Okay. And after that, we are going to create a user-defined function. Okay. We are going to use a user-defined function, a def, guys. Whenever I say a user-defined function, we are going to use def. Okay. So here you can see when I say the user-defined function, I'm going to use a def function, which is the code you can write yourself or any code. Okay. So I'm going to use def function. I'm going to design an MLP. So after initializing the model, dense is 150, input dim is 784, and the activation function is rectified linear unit. Okay. And after building an ANN using trained data set and validation data set, I'm going to design my MLP. So how much of epochs I need? Okay. I am said I need 10 epochs. So it's going to go for every 10 epochs and it's going to do the accuracy, is it good or not? Okay. So after that, I'm going to go for to evaluate model on test data. Okay. I'm going to evaluate the model on test data, and you can see the accuracy for a score test we have got is 88.70, and accuracy for train data we have got is 90.380. Okay, this was all about neural networks, guys. Okay, tomorrow we are gonna come with other concepts. So if you have missed any videos on robotic analytics, you can watch in the recorded videos. Okay, thank you for attending the session, guys.